Hi, I'm Wayne Lack and I'm doing January 2013 Core 3 AQA. We're now on to question 3, and according to my examiner's report, Part A, nearly everyone got it right. There was very few mistakes at all. In Part B, a little bit more mistakes. Some silly errors such as notation and sign errors. And indeed, B Part 2, oddly enough, it says that people either got full marks or no marks. So either know what you're doing or you don't. Let's turn to the whiteboard and go through question 3. So, question 3. A, let's go with that. Find dy by dx when y equals e to the power of 3x plus natural log of x. So this is just a simple differentiation question as far as these sorts of questions go. It is new Core 3 knowledge, but there's no sort of evil formulas or anything like that. You're differentiating each thing separately. So you've got to differentiate e to the 3x, and then you've got to differentiate ln x, but there's no nasty formulas. So to differentiate e to the 3x, you get 3e to the 3x, because you multiply by the coefficient of this x, but then you don't reduce that coefficient. And then the natural log of x, differentiate that, you get 1 over x. And these are just things you have to know. Okay, so if you don't know that, you've got to learn that.
I think I'm going to have to make
B Part 1. So there is a Part 2, but it's going to take up a bit too much room on one board. So B Part 2 will be on the next board. Given that u equals sin x over 1 plus cos x, show that du by dx equals 1 over 1 plus cos x. So it's a show that question. So we know what answer we're going to get to, which is normally friendly. So what sort of formula or whatever are we going to use? Well, if we look at what u equals, it's in the form u over v. Now, just for the second, let's just ignore the fact that this is called u instead of y, and that this is du dx instead of dy dx. This is just y equals something, and this is just dy by dx equals something. They've called it u, but it doesn't matter. So it's in the form u over v. It's got something divided by something else, so we have a formula for differentiating these horrible little things, and that's v du dx minus u dv dx all over v squared. So the first step is to say what our u and our v is. This is why you mustn't get confused, because the u is this, it says u is this. But I'm treating u of v like I normally would if this was y. So u is always the numerator, so it's sin x, and v is always the denominator, which in this case is 1 plus cos x. We do what we always do, we differentiate both, so you get du by dx, and if you differentiate sin x you get cos x, and dv by dx. If you differentiate 1 plus cos x you get minus sin x, by rules you should be familiar with. So, v by du dx is 1 plus cos x, that's our v, times du dx, which is cos x, so it's that times cos x, plus, this shouldn't be a bracket then, plus u, which is sin x, oh I'm putting plus, I'm confusing everybody now, aren't I? Minus, because of our formula, minus, so u is sin x minus times minus sin x, which is our dv dx. All of this is over v squared, which is 1 plus cos x squared. If you expand that out, you're going to get cos x, which is the 1 times cos x, plus cos squared x, plus sin squared x. Expanding your minus and minus. Be careful of your positives and negatives. I know I was an idiot just now. That's over 1 plus cos x all squared. Cos squared x plus sin squared x is 1, which is a difficult thing to notice. So we've actually got 1 plus cos x, or cos x plus 1 on the top, and then 1 plus cos x squared on the bottom. So one of the bottom essentially can cancel out with the top. So our final answer is 1 over 1 plus cos x, which is good because that's what it wants you to get to. part A was worth 2 marks. There was a mark for differentiating e to the x right and a mark for differentiating natural log x right. B part 1 was worth 3 marks. Personally, I think it should have been worth slightly more. I thought that was quite hard to notice some of those things, but it's only worth 3 marks. Obviously selecting the right formula and stuff is going to give you a method mark. Doing all these bits right is going to give you a second mark, and then plonking it all into the formula and boiling it down to what you want is the third mark, because obviously there's no answer mark in this case because it's a show that question. But I personally think that should have been worth 4, but okay, whatever, AQA. That's B part 1, let's get on to B part 2. Okay, so part 2 then. Hence show that if y equals the natural log of, and in brackets, what we just had, our sin x over 1 plus cos x by dx, then dy by dx is going to equal cosec x. So it's another show that question. Now we're gonna use an application of the chain rule here. Because we've got natural log of a complicated thing, that's why we use the chain rule. So firstly, we say that we say that u equals the thing in the bracket, the sin x over 1 plus cos x. And as you'd expect, like we normally do, we find du by dx, and it happens to be that's what we found in part 1. That's why it says hence show. Hence means there is stuff previously that you can use, and we've just found out that that equals 1 over 1 plus cos x. Okay, so we've already done that. We let u be the thing inside the bracket and we differentiate it. We've already differentiated it. That means that what's left is y equals the natural log of u. So we can then find dy by du would equal 1 over u rather than 1 over x like normal, because it's in terms of u at the minute. Now if we then put what u equals back into this, we can say that dy by du equals 1 over sin x over 1 plus cos x. Like that. So that means dy by du equals 1 plus cos x over sin x. We can just flip that around, because it's the 1 over, we can just flip that around. So dy by du equals 1 plus cos x over sin x is what we get eventually following these steps. Now with the chain rule, what we can say is that dy by du times by du by dx will quite nicely cancel out the du's and get you your dy by dx, which is what we want. We have dy du, we've already worked out du by dx, so we can go ahead and times them together. We've got this 1 plus cos x over sin x times by what we found before, the 1 over 1 plus cos x. You'll notice the 1 plus cos x will cancel, leaving you with 1 over sin x, and bippity boppity boo, that equals cosec x, which is lovely. So that's our final answer for dy by dx. Altogether, this one was worth 2 marks, because again, you're not going to get a mark for the final answer, it's a show that question. But selecting and using the chain rule and probably following out this sort of line with the cancelling out is your 2 marks there. So the things people tripped up on in this one, this is the one where you either got 2 marks or no marks. So the things people tripped up on is not noticing that you have to use the chain rule. But when you've got natural log or sine or cos of something complicated, use the chain rule. In a nutshell, that's sort of where you use the chain rule. But people who knew to use the chain rule achieved all the marks. No one got 1 mark and say didn't do this bit. If they selected the chain rule, they completed the question. And that was question 3 altogether. So hope it helped at least a little bit. Let's get on to question 4.